I wanted to go ahead and provide a little bit of a review of how we talk about frequency and period of periodic functions. So our most standard basic trig functions are sine and cosine. And so one of the things that we know, sort of better graph here, is that sine and cosine both have a period of 2 pi, the standard sine and cosine function. So our sine function, if we plotted sine of x versus the angle, so we'll refer to this as t though, and y versus t. If we are taking a look at y equals sine of t, sine starts at 0 at t equals 0, makes its way to 1, comes back down to 0, and then goes to -1 and returns to 0 in a period of time units of 2 pi. And so then we have these other critical points here. This is going to be at pi halves when the sine function reaches its maximum of 1. At pi, the sine function returns to 0. At 3 pi halves, the sine function is at -1. And then at time pi, 2 pi, the sine function returns back to 1. So this is for y equals sine of t. And specifically, this is sine of 1t, and so we want to emphasize that as well. And of course, we could continue to graph this. This is a periodic function, so it'll continue oscillating in both directions. Now, cosine starts at 1 at t equals 0. Pi halves makes its way down to 0, and then at pi, cosine is at -1. At 3 pi halves, it makes its way back to 0, and then at time 2 pi, it makes its way back to 1. So this is y equals cosine of t. Now we can see that sine and cosine are just shifted functions of one another. If we were to shift the cosine function over pi halves units, it would perfectly overlay on top of the sine function. Now in either case, though, the standard period is 2 pi units of time. Now, if I do refer to this as time, I can say that maybe t is in seconds. So I can say that it's going to take approximately 6.28 seconds per one, what I'll call cycle. Now, cycle is unitless. One cycle we're just going to think about as the time it takes for the function to start at a point and then return back to that same point. And then, of course, it'll continue repeating itself from there. Now, frequency is defined as 1 over the period. So if we took, in this case, 1 over 2 pi, well, because it's the reciprocal of period, it's going to have reciprocal units as well. So this is going to be not in seconds per cycle, but in cycles per second. So here we're asking with period, how long does it take to complete a full cycle? Time to complete one full cycle. Okay, and in this regard right here, which 1 over 2 pi is approximately 1/6, 1 divided by, let's see, 2 pi comes out to about 0.16. So that's 0.16 cycles per 1 second. So in other words, I could think about this as analogous to saying 16% of a cycle in 1 second. Let's try that again. Let's try writing that out again. Cycle per 1 second. In other words, in 1 second, which is maybe somewhere right over here, each of these two functions only completes 16% of its full cycle. And that should make sense because it takes approximately 6 seconds to complete a full cycle. So 1/6 is about 17%. But that's a way we could interpret the period and frequency. Now the relationship between, we could also have sine of bt versus y equals cosine of bt. And in either of these cases, period, we can recall period is equal to 2 pi over b. So that makes sense in this case because if our argument here, our parameter is 1, then period is equal to 2 pi over 1, which is just equal to 2 pi. But as you increase the value of b, that's going to decrease the period. It's going to basically make the oscillations occur more rapidly. So for instance, if we had something like y equals cosine of 2t, this would imply that this function has a period of 2 pi over 2, which is equal to pi, or about 3.14 seconds per one cycle. So you can see we've effectively cut the time that it takes to complete a full cycle in half relative to your standard sine and cosine functions. Now the frequency is going to increase because now, since it takes less time to complete one full cycle, that means we're more frequently completing cycles, and this is going to equal 1 over the period, which is just really 2 over 2 pi, and that's going to be equal to 1 over pi, and 1 divided by pi comes out to about 0.32. So 0.32. Now the units are cycles per second, and you can see that we complete double the number of cycles every second. Here we complete 32% of a full cycle per second, whereas with the standard sine and cosine functions, we're completing only 16% of one full cycle. Now the same thing applies if you sum or take differences of periodic functions, as long as the value of b is the same. So if b is the same, then something along the lines of y equals sine of bt plus cosine of bt still has a period that is equal to 2 pi over b and has a frequency that is equal to 1 over the period, which is essentially just the reciprocal of 2 pi over b. And so nothing changes there. We don't have to worry about that. It's whenever these parameters change, if this were b and this were some other value, then that could affect our frequency and our period. But for all intents and purposes, that's all that we want to worry about here.